Hello, I'm Professor Stephanie Watson.
Hi, I'm Dr. Abbasi, postdoctoral researcher. We are from Cornea Research Group, University of Sydney.
So we're here to tell you about stem cells, and that's because they're the body's building blocks. And in the eye, we have specialized stem cells. Those for the cornea, the eye's window, are known as limbal epithelial stem cells, and they divide to produce new cells that can heal the front of the eye. It's a bit like a garden where the stem cells are the seeds and they're producing the flowers, which keep the surface of our eye healthy. But some patients, the surface of their eye is like this. They have dead and dying stem cells. This is known as limbal stem cell deficiency. It's a condition that causes corneal scarring, resulting in discomfort, but critically, blindness for patients. It has many causes, and with chemical injury the most common, and unfortunately it's not treatable with standard grafting. This image here is a patient of mine who suffered an injury from a beer line cleaner, and he's awaiting treatments. We developed a treatment using a contact lens that was able to transplant stem cells to patients with stem cell deficiency with a success rate of around 60%. But 4 in 10 patients still could not be treated. The existing solutions for patients include using tissue transplantation techniques. The trouble here is that large pieces of tissue need to be taken from the fellow healthy eye, leading to failure or stem cell deficiency in the donor eye. Expensive culture techniques have been developed, but they're not available here in Australia, and they have long-term uncertain outcomes. An example of this is Holoclair, which is the only regulated stem cell therapy for the cornea worldwide. Our solution is to develop SightLens. It's a coated contact lens. It uses the CSR's painted technology to enhance stem cell function, as this was missing from our earlier technique. It can be used to culture, transplant, and nurture corneal stem cells. In this diagram, our procedure is illustrated, where we take a small piece of donor tissue, small that it won't induce failure, culture the cells on SightLens, and then return it to the patient's eye to improve vision. So Moji, what excites you about being part of commercialization for SightLens?
Well, I am a molecular biologist with experience in vision science since 2016. I'm investigating sight lenses right now. And what excites me about this program and gaining experience in commercialization is the opportunity that I get to learn how our research can translate from lab to patients' benefits. That is the real world application. So through this program, I think I can learn the skills to explore the commercialization pathways to help to guide our project toward the real world impact.
And why you for this project?
Well, I think I have an excellent scientific record so far. So now I think I'm ready to gain experience in commercialization.
Excellent. And we both agree to the program guidelines and learning commitment. Thank you.
Thank you.